We have been talking about functions, and I hope by now you've realized these are critically important, and in fact the whole reason you're using R, because everything that happens in R is a function call, and you want R to do things for you. There's a special kind of function, and it is called an operator. Operators are special abbreviated functions. Look in my console window and consider 2 plus 3. Now, if everything is indeed an object in R, then 2 should have a class, and it does, numeric. 3 should have a class, and it does, numeric. But what about that plus sign? Well, we indicate the plus sign within these single accents. If I just put plus, I'll get an error message because it will look for it as an object that I defined. But if I put it in these single quotes, now it's going to ask, what is the class of the plus sign in my expression? It's a function. So a plus sign carries out a function. It is a function call when you put plus. When you put 2 plus 3, you're not using the normal kind of function where you have an argument in parentheses, but you're still asking R to do something, namely, take what's on the left side and what's on the right side and add these together. And plus does exactly that. This is an operator. It is a special kind of function that's been abbreviated. Why do operators exist with these special abbreviations? Because they're so commonly used, it would be cumbersome to use the normal function notation when we want to carry out these actions. I could, in fact, create a vector in which I have 2 and 3, and then I could use a function that would sum the elements of my vector and get the 5. But isn't it a lot easier just to use that operator, 2 plus 3? That is actually how we use functions when we use a simple calculator. There are 5 basic groupings for operators: assignment, arithmetic, relational, logical, and everything else, which we'll call miscellaneous. So we're going to look at each of these groupings in turn. Let's start with assignment operators. We can assign in 3 different ways. You notice here that I've created a vector with the concatenate function, but I want to put it somewhere. So I've created an object I'm going to call A, but I need to be able to tell R, hey, take this vector I created and put it into A. That's what we mean by assignment. We're assigning this vector to A, and the assignment operator is this symbol, this little less than with a little dash or hyphen. You can also do it this way if you prefer, with 2 of these less thans and then a hyphen, or you can use the equal sign. Now I discourage the use of the equal sign because equal often means that we're equating, and as we'll see, we're going to use multiple equal signs to check to see if things are equated. So I really recommend you use one of these first 2 assignment operators, whichever you prefer. So if I run this line, you can see that now I have an object A that has the vector 1, 2, 3. Here's B, 4, 5, 6, and here's C, 7, 8, or 9. These all do the same thing. You can even assign on the right side. The assignment operator can point the other direction. So I can assign 10, 11, 12 to D, or 13, 14, 15 to E. So there are 2 assignment operators, left assignment and right assignment. Now let's look at the arithmetic operators. We add using the operator, the plus sign. So 17 plus 23 has been added to 40. Now what if we took two vectors like A and B that have 1, 2, 3, and 4, 5, 6 and added them together? What will happen is that each of the corresponding elements will be added. So the 1 is added to the 4, the 2 to the 5, the 3 to the 6, to give us a new vector, 5, 7, 9. Similarly, for subtract, we use the minus sign, 40 minus 23, 17. And similarly, we can use the subtract on vectors, and we'll get 4 minus 1, 5 minus 2, 6 minus 3, so we get a vector of 3s. Continuing in this same manner, we can use the asterisk for multiplication. 4 times 11 gives us 44. And if we use the asterisk for multiplication of vectors, A times B, it's 4 times 1, 2 times 5, 3 times 6. And so you get 4, 10, and 18. You've guessed it, it works the same way for divide, where we use the slash, that's the uphill slash from left to right. 44 divided by 4 is 11. A divided by B, we'll take 1 divided by 4, 2 divided by 5, and 3 divided by 6. We can exponentiate. So 4 to the third. 4 raised to the third power, which is, of course, 4 times 4 times 4, 64. If we take B raised to the A power, that's going to be 4 to the first, 5 to the second, 6 to the third. So you can see the consistency with these vectors. Each corresponding element is going to have an arithmetic function performed element by element. Then there's modulus. Let's look at what modulus does. 13 modulus, and that's 2% signs in a row, 3. When you do 13 modulus 3, you get a 1. What just happened? Well, what it did is 13 divided by 3, which would be 4, but there'd be 1 remaining. Modulus asks for what's remaining after you do the division. 13 modulus 3 is 1 because 13 divided by 3 is 4, but that's not the modulus. We want to get the 1 remainder, and that's the modulus. Let's do modulus with our vectors. So we have 4 divided by 1 is going to be 4 with no remainder, 0. Then we have 5 divided by 2, which will be 2 with 1 remainder, so modulus is 1, and 6 divided by 3, no remainder. So basically, modulus can tell us whether something goes evenly into another number. Then there's integer divide. Notice it looks a lot like modulus in that it's 2% signs, except that there's a divide between them, that upward slash. What is integer divide? Integer divide is sort of the inverse or opposite of what modulus does. Now we take 13 divided by 3, and instead of looking at the remainder, we look at the whole or integer part. 13 divided by 3 is 4 with 1 remainder, so we're just looking at the 4 part. Notice the combination of integer divide and modulus will give you the division result and the remainder, what's left over. Doing it for the vector, if we have 4 divided by 1, that's a 4, no remainder. 5 divided by 2 is 2 with 1 remainder, but this now gives us the 2 part, and 6 divided by 3 is 2. Note that if you do arithmetic with a scalar, it will apply to all elements. So if I have a plus 4, it will take a and add the 4 to every single element of a. So the arithmetic operators are addition, subtraction, multiplication, division, exponentiation, modulus, and integer division. Now let's look at relational operators. Relational operators, as the name implies, will test the relationship among two numbers. What they return is a logical. So let's look at this first relational operator, less than. 7 less than 5. Is that true? It is not. It is false. So we can check to see if 7 is less than 5. We'll get a true if it is, a false if it isn't. What about A less than B? A less than B is going to go element by element. 1 is less than 4, 2 less than 5, 3 less than 6, so we get 3 trues. Greater than. Is 7 greater than 5? Yes, it is. True. Is A greater than B? No, none of the elements are. It will give us falses and trues for every element comparison that it makes. What about less than or equal to? That's done as a combination of the less than sign and the equal sign. You see why I don't like using equal for assignment? We use it in relational context, like this. Is 7 less than or equal to 5? No, it is not. Is 5 less than or equal to 5? Yes, it's equal to 5, and so that's a true. Is A less than or equal to B? Yes, every element of A is actually less than B, so it is less than or equal to. Greater than? 7 greater than or equal to 5? Yes, it's greater than. 5 greater than or equal to 5? Yes, it's equal to. A greater than or equal to B? No, it's not. And then finally, the equal to. Notice the difference between doing a relational equals compared to the assignment operator. We use two equal signs back to back. So this is asking, is 7 equal to 5? And it's false. Is 5 equal to 5? It is true. Is A equal to B? All of the comparisons are false. And if we want to switch to a not equal, we again use that equal sign, but instead of two equal sign, we now put an exclamation point in front of the equal. And now the question becomes, is 7 not equal to 5? And the answer is, that's right, 7 is not equal to 5. Now you have to start thinking almost in terms of double negatives here. Is 5 not equal to 5? False. 5 is equal to 5. It's not equal to 5. Is A not equal to B? True, 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 because 1 does not equal 4, 2 does not equal 5, and 3 does not equal 6. So the relational operators, which will return logicals, is less than, greater than, less than or equal to, greater than or equal to, or not equal to.